Hey guys, so let's get into some sample questions here. Now, I'm having some technical difficulties, so I don't want to record too much at one time, and I apologize for this being in a lot of different pieces, but I'm, again, having some issues with this. So let's go ahead and get into our sample questions. Come on. So, sample questions. What conditions must be met for the heat of formation to be standard? So, delta H not F. And so this little knot right here, this thing right here, indicates standard. That's what that means. Standard conditions are defined as 1 atmosphere of pressure, 25 degrees C as my temperature, and then forming 1 mole of material. So what I mean by that is that if we were to balance the equation for O2 plus H2, going to make H2O liquid. Normally, we would go ahead and read this as 1O2, 2 H2s, and make 2 H2O. By definition, if I were to calculate a delta H for that, it cannot be the heat of formation because I've made 2 moles of H2O. So the heat of formation has to do with this half of an O2 plus H2 gas, going to give me 1 H2O liquid. So that's what I mean by that. It has to be forming only 1 mole of whatever it is I'm making from its constituent elements. That's what we're talking about. Okay. Now, what is the standard heat of formation of O2 gas? Well, O2 occurs as O2. Awesome. So that's natural. That's the way I would normally find it. And it is naturally a gas. So its heat of formation is defined as 0. Okay? And so that's what we get for that particular value. Now, would the standard heat of formation of O2 liquid be the same as for O2 gas? No. No, and we should be aware of this right now because we've talked about the fact that there are phase changes and we have to put energy in or take energy out to get those phase changes to happen. So if O2 gas is defined as 0 and we're in a lower energy state for O2 liquid, then we must have given off energy to be able to do it. Okay? So there has to be a heat of formation, whether it be endothermic or exothermic, that's associated with the difference in phase. Okay, so there's that. Now this last question, given delta H naught for the reaction, or calculate delta H naught for the reaction, C2H2 gas plus H2 gas goes to C2H4 gas. And I'm going to do that given the information below. 2 C2H2 gas plus 5 O2 gas goes to 4 CO2 gas plus 2 H2O liquid. And that's delta H naught of negative 2599.2 kilojoules. C2H4 gas plus 3 O2 gas goes to 2 CO2 gas plus 2 H2O liquid. Delta H for that is negative 1410.9 kilojoules. And H2 plus half of an O2 goes to H2O liquid. And delta H for that is negative 285.8. Okay, well, that's awesome. Now, I know, beyond the shadow of a doubt, that I need more space than what I have right here. Because I've done this before, so I know that I need more space. So I made myself some more space, and on this more space, I'm going to be looking at those same equations. So I'm going to pull those up on the other screen over here so that I can see what I'm looking at. Now I'm trying to make C2H2 gas plus an H2 gas going to C2H4 gas. This process is called a hydrogenation. So we're adding hydrogen to a molecule to get more hydrogen on it. Okay, so that's a hydrogenation process. Now I have, 2 C2H2 gas plus 5 O2 gas goes to 4 CO2 gas plus 2 H2O liquid. And that has a delta H, which I'm going to, these are all in kilojoules, so I'm going to write that up here. And that's negative 2599.2. My next equation is that C2H4 gas plus 3O2 gas goes to give me 2CO2 gas plus 2H2O liquid. And that is negative 1410.9. We also have H2 gas plus half of an O2 gas to give me H2O liquid. And that's negative 285.8. So those are the values that I have available to me. I'm looking at this equation when I'm trying to form this C2H2 plus H2 going to C2H4. And the first thing that I want to identify is where is C2H2 in these equations that I'm looking at. So I find C2H2 right here. And I see that it's reactant, so it's on the correct side of the equation. But the stoichiometry is wrong. So there are two of them here. I need to divide this equation by 1. I need to multiply it by 1 over 2. So divide it by 2. When I do that, I'll put that down here. And that gives me C2H2 gas plus 5 over 2 O2 gas goes to 2 CO2 gas plus H2O liquid. So we only have one H2O left. Cool, awesome. Now since I divided that by 2, I need to divide the delta H by 2. And so if I take 2599.2 and I divide that by 2, I believe that gives me, no, actually, I don't know. I don't remember. Negative 1299.6 is what I get when I divide that by 2. Okay, so now I've got my C2H2 as a reactant. That's cool. The other thing I'm going to worry about next, because it's the next most complicated thing, is this C2H4 needs to be a product. So I see C2H4 here as a reactant. It's not a product, so I need to reverse this equation. So when I reverse that equation, I get 2H2O liquid plus 2CO2 gas gives me 3O2 gas plus C2H4 gas. And since I reversed that, that's going to be plus 1410.9. Now I could work with the third equation, but for me, it makes more sense, way more sense for me to do this in 2 steps. So combine these 2 equations and then see what the situation is to see how to deal with that other equation that's up there. All right. So I'm going to have, when I start this, I get C2H2 gas. And the next thing I see, so the next thing below it is the 2H2O liquid. But I know that there's H2O liquid over here as well. So I have 2 here. So I can cross out the 2. I can cross out the 1 that's over here. And that leaves me with 1 there. Plus 1 H2O liquid. I have 2 CO2 there, 2 CO2 there. So I can cancel that. I have 5 halves O2 and 3 O2 here. So this is 2.5. This is 3. And I'm going to cancel 2.5 and leave me with a half of 1 over here. So that leaves me with a half O2 gas plus that C2H4 gas. Now all I did was add those 2 and cancel a bunch of crap. So I can take that negative, the positive 1410.9 plus the negative 12299.6, and that gives me 111.3 kilojoules for that equation that I'm looking at right now. Okay, so I'm close. I have my C2H2 where I need it. I have my C2H4 where I need it. What I don't have is this H2 gas right here. So I need to get that H2 in the right place. Now I see this H2 right here. So I'm going to add this equation to the one that's here. So I'm going to write this down here exactly as it is. H2 gas plus half of an O2 gas. And that gives me an H2O liquid, and of course that is negative 285.8. And now I'm going to add those 2 together. So when I do that, notice there's an H2O liquid here, there's an H2O liquid here. That cancels. I have a half an O2 and a half an O2. Those cancel. So that leaves me with 2 C2H2 gas plus H2 gas gives me C2H4 gas. And so that means that if I add those two values together, I am done. That is beautiful. So I take that 111.3, 111.3, and I subtract that, or I add the negative 285.8, and that gives me negative 174.5. And that is my answer. Okay? So I need to manipulate those equations such that I can get the things where I need them to be. And that is how I handle it, is to say, okay, I need this reactant. Where do I get it from? Let's manipulate this to get that in the right way. And then where do I get the next most complicated thing? And I dealt with the C2H4 because if I dealt with the C2H4 and the C2H2, chances are the H2s and the CO2s and all the other stuff will work itself out. Now, it didn't completely, and that's why we had to deal with this equation right here. It's H2 plus half of an O2 going to H2O. But that's okay. So that's how we deal with that. Now, as I said, I've been having some technical difficulties, so I'm going to stop here, and I'll be back in just a couple of minutes. Thanks, guys.